Alright, so now that we've covered all of the formulas for the volumes of different solids, what we're going to try to do now is begin with a two-dimensional shape, and we're going to revolve that 360 degrees around an axis, around a line, and we're going to turn it into a 3D object that we are then going to calculate the volume of. So, look at this coordinate plane. You have a right triangle on the coordinate plane. Now, we're going to rotate this triangle, or revolve this triangle, I should say, two different ways. Once around the y-axis, and once around the x-axis. So you can see these pictures here, but try to imagine in your mind what it would look like if this triangle went towards you, like through the screen towards you, and around this axis, 360 degrees. What would that look like? Well, this is what it would look like. Now, when you're going to, by the end of this chapter, you're going to have to draw these yourself. Draw in the 3D shape. So what I recommend you do is you think back to when we did transformations and do the reflection first. So take this triangle, reflect it over the y-axis. So see how we have the original shape and the reflected shape. And now, everywhere that you're perpendicular to the axis, that's going to be a circle, because that line is going, that segment is going to revolve 360 degrees around. And what is 360 degrees around? It's a circle. So watch this shape right here, this segment. See? When the triangle goes 360 degrees around that line, it makes a cone. Now, see if you can look closely right here where I'm clicking. That is the original, you can see it through there, the original red triangle. If you notice, this vertical line here, the leg of the triangle that was on the axis, that became the height of the cone. The leg here that was perpendicular to the axis, that became the radius of that circular base. Okay? So that's what that looks like. Let's reset. So we're back to this red triangle. Now, instead of revolving around the y-axis, let's revolve around the x-axis. So again, this is the x-axis. First, we're going to flip. So this red triangle is going to flip down, reflect down. Now can you see what that cone is going to look like? This is where the circle is going to be, right here. Okay? So this time, this segment on the triangle, this leg, that's perpendicular to the line we're revolving around. So that's going to be our radius of our circle. And then this leg here that's sitting on the axis, that will be the height of the cone. Anytime you're perpendicular to the axis you're revolving around, that's going to be a radius of a circle. So how many lines do we have that are perpendicular to the x-axis in this case? One. This one right here. So we're going to have one circle. So that's going to be a cone just like last time. So here's what it would look like. Just reset that. You can see it revolving around. And this time it makes a cone, except the cone's facing that way. Okay? So when you have a right triangle that's sitting on the axis, and you have one side that's perpendicular to the axis you revolve around, that's going to make a cone. Now, that's where these numbers came from. When we revolve around the y-axis, this was the height of the cone, which is 5, and this was the radius of the circle. See how the circle is this whole thing here? So, now I go to look at my formulas. I found what's the formula of a volume of a cone. It's 1/3 pi r squared h. R is 7, h is 5. Type it in here. Calculate the answer. And this wasn't asking for the exact answer, it was asking for the rounded. So that's why I rounded. over here, when we revolved around the x-axis, this is the radius, the short side. That's 5 is the radius, and then it's longer cone this way. It's 7 height. Substitute those numbers in and get this volume. Now you can already kind of see my work there, but if you want to go ahead and try example 2, then come back here. Go ahead. This is what I got. Okay, so here's my triangle. We're revolving around the x-axis. Now, just like when we did reflections, what I would recommend that you do is draw in the line first. So this is the x-axis. Trace this line on your paper. Okay. Then draw in the reflected triangle. Flip. So you have this triangle drawn and this triangle drawn. And now you say, okay, where am I perpendicular to the x-axis? This segment right here, that's going to be a radius of a circle. So I go skinny circle. There's my cone. This is the height of the cone. That's 10. This is the radius of the cone because it's the radius of the base. That's 12. Then you calculate the volume. Here's the exact. Here's the round. Now you go ahead and try the next example on your own. Tracing the line that you're revolving around. Draw in the reflected triangle first. Then the circle that you draw in, so you have your cone. Label the radius, label the height. Get the volume. Go ahead. Pause it. Do that. Okay. Did you get this? Revolving around the y-axis is right here. So I draw in the two triangles. It's just a reflection. This is the side that's perpendicular to the y-axis, so that's going to be my radius. So there's my circle. One circle, it's a cone. Now, think about if I have a rectangle sitting on an axis that I'm going to revolve around, right? A rectangle is going to have two sides that are perpendicular to the axis I revolve around. So that means it's going to have two circles. So what is that going to be? So two circles, that would be a cylinder, right? So here's our rectangle. We're going to revolve around the x-axis, that's this right here. So we're going to do the same thing we just did with the triangle that resulted in a cone. We're going to trace the line we're revolving around, in this case the x-axis. So we're going to do that. We're going to trace this line here, that minus purple, flip it down. Now you have the two reflected images, and then you look at this and say, okay, what are the sides of my shape that are perpendicular to the axis? That's this one and this one. So each of those is going to be a radius of a circle. So I'm going to have a skinny circle here, skinny circle here. Well, that's going to be a cylinder. So it's going to look like this. Look at the two circles coming in, both sides. As you can see, it's a cylinder. Okay? Now, that's what this is. This wants me to rotate around the line y equals 4. Remember, y equals a number, it's a horizontal line. X equals a number, is a vertical line. If you can't remember that, just pick 2 points that have a y that equals 4. So just pick like 2, 4 and 5, 4 and plot those points on your coordinate plane and connect them. If you draw that in, that will give you this line here, which is y equals 4. What would that look like here? That would be like this. So here we are. We're going to flip over this line. We draw those in. And once again, it's going to be a cylinder because we have two sides that are perpendicular to that axis. Okay? So we get these numbers. This is the radius. That's 1, 2, 3, 4. The height is the distance between the two bases, if you recall back to a cylinder, right? Well, this is a radius of a circle. This is a radius of a circle. These are the two circular bases. So what's the distance between them? Right here. That's 6. Now you can tell because, just like with the cone, the side that is sitting on the axis that you're revolving around, that's the height right here. That's 6. And then the sides that are perpendicular to the axis, that's the radius. So in this case, 2 radii, 2 circles, it's a cylinder. Here's our calculations. You notice it's the same volume, it's the same size cylinder. One of them is just lower than the other in positioning on the graph. Okay. Here's another one. Trace the axis, flip the rectangle, draw in your 2 circles. This whole circle is 6, so the radius is half of that, 3. The length between the 2 circles is 7. Calculate the volume. And what's the volume of a cylinder? Pi r squared h. So now you go ahead and pause it and do the next one. You're going to draw and trace the axis, draw in the reflected rectangle, draw in your 2 circles, figure out the radius and the height. Calculate, come back. Okay, here's what I got. So this is the rectangle. We're going to rotate around x equals 2. So again, if you don't remember if that's vertical or horizontal, just go like 2, -2, and 2, 5. That's these 2 points here. And when you draw it in, you get this blue line. So you're going to flip this over to the right. So because this is 1, 2, 3, 4, 5, 6, 7 to the left, you're going to go 1, 2, 3, 4, 5, 6, 7 to the right. You'll be right here. There's your rectangle. This is the one that's perpendicular to the axis, so that's the radius. So you're going to have 2 big circles here, and then you're going to have this short height here. 1, 2, 3. 3 height, 7 radius. Pi r squared h. Substitute these numbers in. Here's the exact answer. It's units cubed because it's volume. And then if you wanted to round it to the 100th, you would just do 147 times pi. So for these, what you're looking for are right triangles and rectangles. A right triangle that's sitting on the axis is going to make a cone. A rectangle that's sitting on the axis is going to make a cylinder. And that's because however many sides that you have that are perpendicular to the axis, that's going to make a circle. And then any side that's sitting on the axis, that's going to make the height. So you're looking for cones and cylinders. We're going to step this up a little bit with a little bit harder objects in the next one, but just keep in mind you're looking for right triangles and rectangles in the next session.